All right, it helps if I turn on my microphone. So yes, I was muted. And I am actually recording before you guys ask me that. I managed to record, but forgot to turn on the what do you call it? The microphone. It doesn't help that I have like multiple ways to turn this off. So you guys, can you actually hear me now? All right. So with the HTML files, there's a question here about having some problems hearing or accessing the HTML files. I apologize a little bit for the way the course is run. MD files render. We're pulling in modules from all over the place, developed at different times. So there are some inconsistencies in the way things are actually pulled together. But MD files render very nicely in GitHub. So as I move forward, I'm pushing more and more things into MD files. The problem is we can't do a CSS or something to really make them pretty. So we do lose out on that part of it. But overall, I think it's probably a fair trade. When you go to the HTML files, what you'll find out is, let's see. They're very pretty when you view them, but when you come in there like this, right, you get something that looks like this, and that's just the raw HTML. What you really need to do is you need to download, probably by cloning. It just looks like this. So, what you really need to do to view these effectively is to do a git update or clone the repository, and make sure you clone you do a git pull from the repository, and you'll be much more aware of how to do that after this lecture and lab. But if you pull these down, you can do something like this, right? Where what I did was I'm actually on the WSL. I'm doing all my slides there. But you just give the path to the HTML file, and it's a nice self-contained directory, and it comes up really nicely. So Markdown files, that's why we're using Markdown files more and more, is just because they render really nicely in GitHub. They're very portable. You don't have to know anything, about the system they were generated on or anything. They're not binary. They're just text files. I'm going to keep my office hours for now, Tuesday 10 to 11:30. I'm still evaluating that. It makes a really rough day on Tuesday. But there haven't been so many questions that it's kept me from getting stuff done. So I'll keep it this way for now. I'm going to do it in WebEx, and the reason I need to do it in WebEx is because not everybody has access to this Nook or to Discord, and I do have other classes and other people I have to talk to. So I'll do mine in WebEx. Our TA, Kevin, Thursday, 4:30 to 6:30. And then the rest of the mentors, Hunter, Jeremy, Avery, Stephen, and Ethan, they all have at least some times when they're available. I think Jeremy is doing it in WebEx. That may change if he changes his mind. I don't think I got an update from him. And the same with Ethan. But we will keep this up to date, and you will always be able to come in here and see when the office hours are and where they're being held. A lot of our TAs are going toward Discord. And, as with everything else, this is subject to change throughout the semester if we find Discord is not a good solution. Jeremy, it's easy. It's up to you. It's a negotiation. This is open source. We are the king of compromises, or the royalty of compromises, not to be gender specific. Anyway, so that's the first thing I wanted to talk about. We do have that updated now. We at least have our first good cut at that. So that's good. I know that we've actually held office hours. I held them yesterday. We had TAs and mentors hold them Wednesday and Thursday. I guess, it would have helped if we would have announced them better, but I was trying to make sure we had everything solid. The other thing is today is a Git lab. So we're going to run through a lot of the components. What I promised you was that I didn't get through all of the Part 2 Git introduction. But basically what the Part 2 does is it runs through essentially a lot of the stuff that you need to do for labs. So it helps you to set up workflows. It shows you what workflows look like. It shows you at least the preliminary, the easy way of, or until you get in trouble way of working with your repositories in like a blessed or a collaborative, collective organization. I'm still going to run through that. We'll run through it relatively quickly. You can follow along if you'd like. I did some major revisions to it so that it flows much better now. So if you have this pulled down from Tuesday, please pull it down again. I think it's better now. But we'll run through this. If you don't have Git installed, if you run out into issues, that's okay. You'll go through much the same steps in the Git lab. And I'd like to get you guys to working together in the Git lab as well, because, quite honestly, for me, it was kind of rough running through this whole exercise because Git is not all that friendly, or GitHub is not all that friendly to having multiple accounts. And I had to use a private window and then a different account. And then I still ran into issues with my SSH keys and I was trying to run through everything. Let's get you guys on it. If there are any issues between myself and the TAs and mentors, I think we can get through it. Anything else? I think maybe the only other thing I wanted to point out was we currently have the office hours in the README. We also have them in the syllabus. And I'll be pushing the syllabus to APHIS hopefully this weekend before they close it down and I can no longer do it. But all of the data is here. It's changed just a little bit, just to reflect the current office hour organization. All right. Any questions on that before we go get started, or move into a quick run through of some of the Git operations? Hopefully, I remember everything that I did because I did this yesterday and the day before. It seems like I should be able to remember that, but it got complicated. All right, so the first part of Git, we were kind of talking to you about, some getting yourself set up, getting your account set up, getting it so that you're all players in the Git world. Now we're going to talk about some specific use cases on how we use Git. By the way, I think I may have resolved my. I shut down everything and I'm simplifying the way I'm accessing my code and nooks and everything like that. And so far, we're not running into any issues with the rendering engine not keeping up. So hopefully, fingers crossed, our recordings will start being of better quality as we move through the next couple of lectures. Of course, having said that, now I'm mucking around with things. Okay, so again, ProGit. Chapters 3, 6, and 5.1 will kind of get you what we're talking about here. And there's a lot more with Git that we should be actually aware of. So hopefully, I think we've already gone through this. But this is how you clone a GitHub repository. This is a repository named Open Source Software Story. So it's just a little repository I set up to kind of serve as a placeholder organization for us so that we can kind of see how to use Git. The GitHub username, right, is WD Turner. So if you want to clone somebody else's GitHub repository, their username would go in here. If you want to take it from the Arcos repository, this would be Arcos. And then this is actually the name of the repository, ossstory.git. The clone, what it does is it goes out to the remote repository, right? In this case, OSS story under my account, and it pulls down. Thank you, Kevin. I will eventually get all this figured out again. I was getting really good at this at the end of last semester, and then they gave me a month off, and now I am completely fried. Okay. So this is the git clone command. It just pulls down. It goes to this place, this user, git at github.com. WD Turner is the username of who you're trying to pull down. That happens to be my username. And then ossstory.git is the actual repository name. And what it does when you do that clone is it goes in and it makes a nice little repository. Let's see, where am I? That is not the window. That is the projection of the window. Okay, so it makes a nice little repository. So I can go to what dot. Right, so I have OSS story. It just creates that here, right? And if we do git remote and type it right, -v, right? This is exactly what you fetched down. So when you pull down a repository, when you clone a repository, it gives you everything under the repository, right? This has a license, a README file, and then 3 directories: Spring 2019, Spring 2021, and Summer 2019. If we look a little further, Spring 2019 should have some stuff. Summer 2019 should have some stuff. Spring 2021 should be largely empty except for a README file. Any empty directories get pruned, at least the way I have it set up. So I have to put something in there. So I just put in a little README file to keep things copacetic. So once you've pulled down the repository, you can do a CD to get into the repository. And remember that most of what we're going to be doing here is going to revolve pretty much around Linux. So you have to get used to it. Git Remote -v I already did. That's the next slide. And what that does is shows you that when you do a clone, what you've set up is this kind of origin pointer that points back to the place you cloned from. That doesn't mean you can push back to it, but it means that you can pull down, and if you have permissions, you can actually push. So this is what we have right now. If you guys all have kind of downloaded that, we have something that kind of looks like this diagram here. Like this diagram here, without all the additional overlays. And each one of you is a developer. You've pulled down the shared repository, and you have pointers to the shared repository and from the shared repository, and that's the remote or the origin remote. There's a way to add collaborators. Collaborators have more access than just the general public. So if we come into the Git repository, right, and we go to the OSS story, we can go to settings up here. And we can go to manage access. Confirm a password. Sorry, just taking a note on something. All right. Confirm a password, and then we can come in and we can do something like, invite additional collaborators, etc. Or come in and manage the collaborator list and get rid of people who are no longer with us in that they've graduated or have moved on to greener pastures in non-CS places, non-OS open source software places. Okay, so if you want to set up Unfettered access, you can do that by setting up collaborators and giving them permissions, and then somebody who signs in with the correct credentials can actually push into the repository. But in general, we don't do that. It's good for small groups. If you're running a project with 2 or 3 people, that's actually a really good way to manage it. It's called a centralized workflow. Everybody pulls from and pushes to the same repository. You still want to set up rules on how you do that, and we'll show you how to do things like branches and pull requests a little later. But the idea is you can set up a centralized workflow where everybody's working from the exact same repository. That was more popular in the opening days of Git and GitHub, less popular now, but it is still an option. You can still do it. And if you have a small group, at least until you start transitioning from a small group into a big group, where does that go to? Oh, cool. Yeah, this links into the 5.1 distributed, your different workflows. Cool. I'm glad I did that. Anyway, small groups can still use that. It's not a bad thing. What you'll find, though, is that most of the time that's not the preferred workflow. Things get too cluttered. If you have too many people in there, people start stomping on one another. And if somebody breaks the rules by not branching correctly, like I will admit that I don't branch when I am working on these course slides, just because most of the time I'm the only one working there, and branching is just kind of a pain in the neck. This is another kind of workflow that's much more suited to large agile development. And in that case, there's this one special repository. For example, maybe this belongs to the Arcos organization, and almost nobody can push into it. The only person that can really push into it is this integration manager, and they get to push the button on whether code gets included or not. They get to decide. On the other hand, it is an open source repository, so all of the developers can clone it, and they can have the ability to pull down new code from it. So as this moves forward, they can keep in sync in their own private repositories by doing a git pull from, generally this is called the upstream. But not everybody is pushing back to here. And everybody has to push someplace where this blessed repository can get it, so this guy can decide whether to publish it or not. So what happens is everybody keeps a fork of the repository. They keep this, generally, if it's a GitHub project, they keep this out on GitHub themselves. And then when they think that they've developed a feature or they've fixed a bug, they have a branch, they do a branching structure, they in their own private development, in their own public version of their developer private repository, they take that branch until it fixes the bug or establishes the feature or whatever they're trying to accomplish. And then what they do is they send it back for evaluation by the integration manager. And by the way, this integration manager at this point, he's not the only one evaluating. He's just the one with the final ability, the one or the small group of people with the final ability to actually push the button. But it gets pushed out to, for evaluation. We evaluate it here. We make sure it does what it's supposed to do. We make sure there aren't any more bugs. It doesn't introduce more bugs than it fixes. And then they push the button and it gets into the blessed repository. And then everybody can, again, pull it down and get the changes in their own private repository. And this is called a blessed repository type of organization, because this repository, the one in blue, serves as the beacon of truth, as it were. It's the one that actually is where everybody external to the project should be going to get pulls, to pull down the latest and greatest code. It's expected to be correct all the time. It's not expected to have a large number of errors in it, whereas all of these things are being developed publicly, are actually under active development, and they may exhibit bad behaviors. One thing to note is that these are all forks, and in open source software, we'll talk about forks a lot as a bad thing. That's a slightly different context. A forked community is a community that has split but has no intentions of coming back together again. The intention of these branches are to be eventually brought back into and be brought in sync with the blessed repository. They are still developing the same project. A forked repository is one, a fork, a formal split is a split in the community itself. Generally, it's not a good thing, although, like everything, there are good and bad reasons to do a fork. But what that means is that now this blessed repository is perhaps replaced by another blessed repository over here, and some of the developers have gone this direction, and other developers are still going in this direction, and people are, cats and dogs are together, and people are fighting. They're not always fighting. Sometimes they're very amicable. But the idea is that one group of developers has decided that they want to take the shared open source code in a different direction. And because of the open source licensing, this is allowed. And that's actually one of the things that you have to be aware of in open source, is that because the code is open source and because a large number of your developers are going to be developing volunteer or, without, they're not under your control, keeping the community happy is actually kind of difficult. And keeping the community happy is actually one of the jobs of a good integration manager or a good community manager. If you are going to serve in that position on a project, you need to find a way to develop consensus, or at least be so brilliant that no one questions you and you can do it by the iron fist of fate. Okay, so that's done. So how do you create these workflows, right? Well, I already showed you how to create the simple one, right? We just did a clone of the repository and we got this, right? Every developer has this pointer to the shared repository. But what we want to do in order to build something more complicated, such as this, is we have to kind of muck around with our remote pointers. Right, so if you followed this so far, you already have your local private repository, and the local private repository has an origin pointer, and that origin pointer points back to my version of the repository on GitHub. You have to go in now, and you can do this in a different order, but this is kind of the order that forces us to learn more about what we're actually doing. But you can go into GitHub and do a fork. So again, this is a good fork, not a bad fork. The way you do that is you go to the GitHub site. Here we go. We go to the GitHub site and we go into the code thing. And you see this little fork up here. Well, there's 52 forks of this repository already, and we can look at all 52 of them. But we can also go in and we can fork this repository. I've already forked it. I've forked it a number of times. I'm not going to fork it again. But if you fork it, you just have to say who you want to fork it to. And I've forked it into Arcos before. So let's see where Arcos is. And I can go to that Arcos fork and we can look. And it's exactly the same thing as the other fork, except up here it says Arcos instead of WD Turner. Okay, and it has all the same code, at least initially. You can diverge once you have these public forks. But in general, like I said, our goal is to make this consistent. So we're going to try to bring everything together in the end. So once you've done that, you'll actually get a fork. And notice that this says Git Branchy Story. I decided that was way too long, so I changed it. I just didn't change the slides because, well, I didn't change the slides. Once you've forked it, you can get your, and this is a little different. It's changed a little bit from where it was before. But you can get your clone password from here, your path to your site from here. Just click the little thing to copy it, right? Just as if you were going to clone it. But instead, this will just kind of give you the link to it. And now go to your local private repository. So this is on your handy dandy notebook here. Right, and you can do something like, we know that you already have the remote branch for origin, right? So you can type in, I can't tell which window is the window and which window is the reflection of the window. So you can do something git remote -v or -v, right? And it tells you that this origin is where you want your pushes and pulls to come from. So right now they're going back. We have a collective repository structure. So right now they're going back to my repository, and I don't have the time to add all of you into it, essentially. So what we're going to do now is we're going to build a different kind of structure. We want your origin pointers to go back to where your public clone out on GitHub is. So you can do something like Git Remote Set -URL and give it the name that you just copied, right? And for me, it's going to be exactly the same because mine is mine. But you do that and you hit return. I'm sorry, set URL, the remote you want to set, so origin, and then that link, right? And that'll set the origin pointer to be that origin. We go down to the OSS story one. Yeah, there we go. Okay, so now for the origin pointer on the Arcos one, I've set the origin pointer to point to its own repository. This is going to be the repository where you do your own personal work, where you get everything to the point where you think it's working correctly, and so on, before you push it to the main. And if you do Git Remote -V, you'll see exactly that should be -V, I think. Does one dash work? I might be wasting a keystroke all this time. Dang it. Okay. Well, -V works as well. Okay, so now we've set up a repository where we have this kind of organization. We don't have any of these pointers anymore. All of these have gone away, and all of these have gone away. So all of the grayed out pointers have gone away. We have the blessed repository with the integration manager. You guys have your public sites and your private sites, and you have these nice black arrows, and it actually goes both ways. These should be double-headed arrows. So now what we want to do is we want to set up a workflow where we're going to give you access to other people. And the people we're going to get you access to are the people in your table. Again, we'll try to walk through this. But, I'm not going to spend a lot of time here because in the next, 10 or 15 minutes, I want to get through this so I can turn you guys loose on the lab. But, everybody's repository should be the same except for these characters here, right? It should be their GitHub account name instead. And what we want to do is we want to add them in as remotes so that you can pull from your team members. So maybe you're co-developing, you're working on some pair programming stuff, and one of you has made some changes and you want to sync up. So you're able to pull from them. We want to set up some additional links. I'm going to do Git Remote delete Wes, remove Wes, okay, so Wes is gone. Now let's say one of my teammates is Wes. I would find out that his remote repository is WD Turner at OSS story. So we'll do a Git Remote -add Git Remote Add WD Turner at OSS story.git. Git Remote Add Wes. Man, the command is too long. Too many parameters. Okay, and now if we do a Git Remote -V, what we find out is that we have another remote repository called Wes, and we could do something like Git pull Wes master, and that'll pull down from the Wes repository, any changes that I've made, that Wes has made to the repository, and allow us to merge it into our data. Okay, and we can do a Git Branch. Okay, and you can do this with your entire table. And by the way, just as a cautionary note, you probably don't want to do that with the Git link. Use the HTTPS link instead. Sorry about that. I should have told you that sooner. Okay. You also want to add an upstream, and the upstream should be the address of the centralized repository. So this is the address of the blessed repository where you want to push things eventually, because this is going to be where you pull from when you need to get up to date. So if you come in here, again, this is pretty simple. It's much the same as we had before, but you may want to do something like Git Remote Add Upstream, and for me it's pretty simple because it's the same as Wes, and I'm my own table mate. So you can do this, and now you can look and you can see Git Remote -v. So what's going to be happening is we're going to be making changes to our origin, right? When we've got them, and we might trade them around. Set remote does nothing. This should be Git remote. Okay, now we have the upstream. Good. So we're going to be making changes to origin. Every now and then we're going to want to share with our friends, and we'll allow them to push or pull back with, share code by pulling from theirs, or share code by letting them pull from us. And then when we get things finished, we will go through a pull request step that I'll show you in a few minutes. And once we've done the pull request, then everybody else will want to pull from upstream to get our code back into theirs in the integrated fashion. And that's pretty much the workflow that we want to generally do. Okay, so now that we have a table, what we have is we have the ability to pull from somebody else, but we don't necessarily have the ability to push to somebody else. So I showed you how to manage access. It would be good on a table for the next couple of exercises to put yourself as a collective environment. So we can add everybody, if you go in and add all of your table mates as collaborators, I kind of showed you how to do that already. But if you do that, then we have a workflow. And the workflow looks something like, let's see, I was playing with this yesterday. So I'm going to keep the blessed repository with me here, and then this will be kind of the table flow from here out. Let's say your table has 3 people. The first thing you did was you set up this. Right? Everybody had their own clone of, their own clone of the blessed repository. Then what we had you do is we had you clone the repository. So this was your public face. And then we had you get rid of this, right? This was the origin pointer. And we made you put your origin pointer pointing to here. Oops, yeah, origin's black. All right, then we had you form a connected graph. This is via the Wes and the Aaron or whatever other pointers you had. And then we had you guys add each other as collaborators. And once you did that, anybody you added as collaborators could push or pull from your repository. That may be overdoing it a little bit. It may have made sense to just pick one of these as the collaborative soul. But either way, this would then be this is kind of a collective kind of flow. And then finally, we had you put back in the pointers to here as upstream pointers. And actually, this is going to you don't have write permissions there, so this is going to be solely pull this way. Any updates we're going to make are going to come down through a pull request through the manager. Okay, so that's actually what you guys have set up, and it's not all that hard. I mean, you guys did it in just a few minutes, and if I would have talked less and typed more, we would have gotten through it a little bit faster than that even. Oh, and that sucks. There we go. When we have more light, the camera goes dim, and I forgot to turn off my big shiny lights. If I don't have big shiny lights, then I disappear. I get subsumed by the background. All right. So that's what our workflow looks like. I'm going to walk through this pretty quickly, but I think it probably makes sense to walk through this. When we're generally working now, where am I? I'm in Arcos version. When we're generally working now, what we're going to want to do is we're going to want to do a branch. So each table can do something like Git Branch, or each group can do something like Git Branch table 1, right? You can get your table off the interface. Git checkout table 1. Right, now if we do a Git branch, what we see is that I have two tables. I have table 1 and master. Well, I'll leave it for table 1 for now. I should have made it table 0. I think I'll do that. Git. There's an alternate way to do this that's a little faster. I'll be table 0 so I don't mess with anybody else. Switch to a new. One of you should do this if you're keeping up. We're now in table 0, and I can do a Git branch -d table 1. Okay, so now I'm on the table 0 branch. Go into the current semester, spring 2021. I can look around here. There's just a README. I can make a directory for my table. Right, and now I can go into that table. Now again, empty directories don't count in Git. Some directories with something in them do. So having been here, I can come in and I can use a real editor, not nano, and edit table0.md and just put something in. Right, and now what I have is I have a repository that's out of sync. Right, so I have the current directory, the table 0 directory is not in the repository. I can add that in, git add table0.md, git status. Right, and now we have a new file, table0.md. I can go back to my master, right? So now I've done development in a branch. I will work in this table 0 branch until I have it, completely fixed. Everything's cool. I know that we're good. Now I will check out master. right? So now we have, and if we look, what we find out, oops, wait a minute, sorry, missed a step. Okay, I gotta commit this. So we'll do git commit -m. Okay, so now I'm on branch 0, nothing to commit, working table clean. I can check out the master. Right? And now I get this fatal error, unable to read current working directory, no such file or directory. Right? I added a directory on branch table 0, and that branch, this directory doesn't actually exist in master. Right? There's the README branch or the README file that was in there originally, but the table 0 directory and table 0 don't exist. They only exist on the table 0 branch. And we are no longer on that. Right? We are on master. And by the way, they're changing. Master was the way we refer to this since the formation of Git, but they are now encouraging everybody to go to main. You'll probably see some stuff on that. Feel free to do that if you'd like. Right now, I have way too many notes that say master. I'm not going to be able to do that, at least for a while. Anyway, so what we want to do now is like I said, we're assuming that we've gone through and we've done some development. We think everything's good, and we want to pull this table 0 into our master, and we want to make sure that we test it with any other development that's gone on with our teammates. So I can do a Git Merge Master. And what that does is it takes Git Merge table 0, sorry. So it takes table 0, all the changes that were put into table 0, and pulls them down into the master branch. And now if we look, we actually have the table 0 directory, and we can do something like less table 0, table 0.md, and we can see all the great things I typed into there, which was not really anything, right? And now all right, I missed a step. Let me just go back here. One of the things that I should have told you was to choose one of your table to host the centralized repository and make them the upstream. Don't make upstream the WD Turner branch, because you don't have the permissions to write there. But since you've added everybody as collaborators, everybody has the right to write into the upstream on your own table. So every table should have their own upstream pointer. I can actually write into my own upstream. So I'm going to write into my own upstream and pretend. Well, I'm just going to push it to. I'm just going to push it to. Oh, here. Let me get set URL upstream. I'm going to set upstream to be my Arcos master. Okay. Now, in general, this next step shouldn't have any issues because you're pushing to your own local master. But you may get an error message when you do a push. There's a reason, that's not unusual. But for this one, now I have my Git, my upstream pointing to Arcos. So now I can do Git push upstream, the repository I want to push to, and the branch I want to push. And the branch I want to push is my master branch, right? And so now if we go into Arcos here, the Arcos fork, what we'll find is that Spring 2021 has our Table 0 repository. And it has my brilliant observation something in a file there. Okay, so we've made our first commit to our upstream master. Oh, you guys didn't get to see that, did you? Right, so if we go to Arcos OSS story, we can come into Spring 2021, and there's our Table 0 directory and my brilliant selection observation, my something observation. If you do get that message, all you have to do is synchronize your current master to what's already been there. So if somebody beats you to the punch, that's one of the things about Git is one of the reasons to push early and push often is that you want to make the other guy have to do as much work as possible and not yourself. Good programmers should be lazy. Do as little work as you can because you'll do enough work. What you want to do is you want to keep yourself from having endless work. So if you push early, then the next person in is also hopefully pushing early. So if you get any conflicts, they should be small conflicts. And the person that comes after you, if they have any conflicts, they should be small conflicts as well. So push early, push often, at least when you're doing this collaborative type development. If you do run into an issue, pull the upstream master and then push it again. This will merge any changes in. You'll have to get rid of conflicts if you have them, and then push it back. And keep doing it until you get it. If you keep getting that error, keep doing it till you get it right. Because if you're in something going fast, people may be coming in the time you're resolving one issue. They may be doing other issues. Everybody else should sync to this by pulling from the upstream and then pushing out to their local, to their own public repository, their own version on GitHub. And if you look at that under recent logs, we can run through some stuff here. Right, we can do a Git log. And you should start seeing all of your stuff start showing up, right? It goes from top to bottom. So this is the most recent stuff. I started the team directory, and then you can see a whole bunch of stuff here that happened when I was messing around getting this ready and trying to, and from previous semesters. The log tells you who did it, right? I am here. Since we're advocating ourselves, I'm here. And it tells us when it was done, and it gives us the little paragraph on, this is automatic, and then this is what we tell to we write to explain what we did or why we did. And if this is too long for you, you can do something like Git log one line, which just gives you the headings from everybody. But you can see a lot more of them more concisely. At the top is over here is a hash. If we do the long style, we can see that the hash is a long string. As long as you give a unique prefix, right, give the start of the hash, it can uniquely identify it, but that uniquely identifies every commit. But you can shorten it since it's unique. As long as you give a unique prefix, it will be fine. And if you do a git show, on something like 375D61, right, it will show you the specifics of that commit. Okay, at this point, we're going to run through a little bit more of an exercise. I'm not going to do this too much because we're past the time that I wanted to spend, and you will kind of be able to run through this on your own as part of the exercises. But let's just go through, I'll just kind of flip through the slides on this one. Now go into your directory, your Team 0 directory or your Team 1 directory, Team 2. Pick a character name, create a file with that name, and give an extension .md. The idea is we're going to write a little story. Inside the file, write one sentence describing the state of the character. Wes Turner was despondent because it took him way too long to get to this part of the presentation, and he thinks that we're running out of time. Add the file, commit it, pushed upstream. You know, you may get an error message. If so, just keep doing it till you get it right. That just means somebody else is faster than you. Update your local repository and push again. Edit once you've done this, once everybody's gotten their first commit in, pull it back down again from the main repository so you're all consistent, and then edit the state, change the state. Do that on a branch, create the branch, select the branch, add your changed file in, and then commit. Merge it into master, you know, so that's all this stuff here. Merge it into master. And push it upstream. Again, you'll probably have some problems with committing. Repeat until it works. When you're done, everybody should pull the upstream. And after everybody's consistent, push it to your local public. Git push origin master. Origin is where yours is derived from. Finally, the part that I wanted to get to was making a pull request. And this should be done once you've collaborated on getting your story written to the extent you need it written. You should do a pull request, and you should do a pull request to my repository. So come into my repository, WD Turner at OSS Story, and generate a pull request. Right? Click up here for a pull request, do a new pull request, and pull from base master into I'm going to have problems doing this because I am on too many places here. Actually, no, I'm in the wrong place. Sorry about that. Here we are. Go into pull requests on your repository. Create a new pull request. The pull request will go back to my repository, and it will try to pull your master into my master, and you create a pull request. And then I will be able to and leave me a little note as to why you're doing it. There we go. Okay, and then I can go into pull requests and actually see those. Not sure why that was giving me such a headache, but I think something was weird. Anyway, I'll walk through that and make sure that works. But make a pull request. that's how you get from that's the collective workflow is what you guys worked on together. And now we're trying to get this back into the Bless repository. And that's basically the pull request part. All right. I'm sorry this took a little longer than I expected. But I think it's a good tie-in to the Git Lab today. I'm going to go through and pull up the Git Lab for you guys now. It is a table activity. So I think, and it's also on our GitHub account. I think the main thing is step 1 just gets you set up. Hopefully you're already set up. Step 2 has you fork a repository and put some stuff into it. It's not a very exciting thing, but it does get you going through, some of the practice stuff. Should be pretty fast. Part 3 is where you actually walk through this kind of exercise. So, it might be useful to kind of concentrate on part 3 using the instructions from these slides to kind of help you walk through the exercise that we just went through. If you went through this exercise, you'll find this really simple. If you just kind of watched, it shouldn't be all that hard because it basically sets up exactly what we did here. Anyway, knock yourselves out. Please go forth, and let's start going. Thank you, Kevin, for handling that question. Are there any questions that I missed? If not, our TAs and our mentors will kind of be around in the different rooms, and let's get things started. Raise your hands if you have questions, and we will try to bring you up or pop you in or something. If you're working alone, join one of the tables. This is a lot harder to do on your own, and that's kind of where I got stuck last night. Why I missed a couple of steps today is because without having other people there, you don't always think about these things. All right. Awesome. Oh, and I think the gradable, the Lab 2 gradable is up. To my TAs and mentors, I don't have the rubric on it yet, but I will have that on shortly. And please get Lab 1 graded so that we can release grades to these fine people. And the lab is due Monday at midnight. Just to one other thing. I think Kevin Boyle asked about rebasing. If you go through part 2 of the GitLab, they talk to you about rebasing in the first 4 levels. It's actually the 4th level of the introduction sequence, part 2, step 8. I'm happy to go over it. But while you guys are working on that, maybe I'll just talk through that as well, just because otherwise I'm sitting here. So when you do a merge, right, so, and this is something that will, like I said, you'll go through in part 2, step 8. But when you do a, so you have your master moving ahead, and this is like a commit. Not like a commit, it's a commit. And you have a sequence of commits that represent the state of your software or your state of whatever. And now you do a branch. And you make another sequence of commits. But while you're branched, somebody else comes out and they're doing something too. So this is collaborative development, right? This is actually what we want because that means we're getting stuff done. If you do a merge, Git comes in and creates a new commit that takes and pulls these two together again. So for merging back into master, right? This is master, you know, this is master or main. We'll just call it M. And this is the branch, right? So master's marched on. And that could be because other people merged or branched and merged or however it marched on. When you do a merge, what happens is you generate another commit, and that commit pulls together the current master, the current head of master in C7 and C5, and comes up, pulls those all together with a merge commit. And this branching is explicitly represented in the code. It would look probably more like this, right? So that branching is explicitly, this branch that comes out is explicitly represented in the code. If you do a rebase, what happens is, instead of doing this, instead of representing this branching structure so that you have this extra commit down here, what it does is it says, okay, let's pretend that this branch didn't branch off from C3. Instead of pretending that that branch branched off from C3, what we're going to do is we're going to break this. These will become, in some ways, phantom commits, and we'll generate a new C4 prime that gets us from C7 to the C4 state, right? So the combination of, we apply this change on top of C7, come up with a new C4 prime branch, and then a new C5 prime branch. At the end, the contents of main are the same, but we've kind of lied about how we got there. And the nice thing is, though, that this whole complication goes away. So you don't have to represent that anymore. And it's easier to understand, and it makes a cleaner kind of history. You know, so it's good if you've kind of backtracked and made a lot of mistakes, or you want to, you want to represent things differently. And that's basically, what you do with the rebase is you just kind of, instead of representing the history as it is, you represent the history as if you didn't actually branch. And C4 prime will be slightly different than C4 because it has to represent, the effects of applying C4 on top of C7 instead of applying C4 on top of C3. But other than that, the endpoint will be the same. We should probably do like a whole semester on Git, because it would be a lot of fun and I would learn a lot, because every time I pick up Git, I learn something new. But boy, it's a complicated mess sometimes. I used CVS and SVN for years before I used Git, and I can tell you that when I first started using Git, I absolutely hated it. Even today, I occasionally absolutely hate it. But it is arguably better than... I hate it less. When you use it all the time, you end up hating it less than you hate everything else. So that's actually kind of a positive, I guess. You start appreciating its beauty. Okay, and just for one more thing. When I do that, and my little camera is up, can you guys read that, or is it mirrored? It's mirrored for me in my view. Okay, good. Then I will ignore the fact that it's completely mirrored for me. Bingo. If we're despondent because our lecture ran too long, I should be on an iceberg instead of a beach.